The following presentation is part of the Technology and the Corporation Conference Series, sponsored by MIT's Industrial Liaison Program.
Looks good. So as JJ already said, I'm Matthias Winkenbach. I'm leading the Megacity Logistics Lab. That's the official name of that research initiative over at the Center for Transportation and Logistics. We are currently a group of around 8 people, from basically senior researchers down to undergrad students, so across all levels of possible engagement with researchers and also students. And we deal with questions about how to serve large urban centers with the goods that they need to do business, but also with the goods that consumers need to survive, basically. And therefore I wanted to start with giving some kind of motivation why it's actually relevant to think about cities, and in particular megacities, from a logistics point of view. This graph, it's not most up to date, it's from 2011, but it was taken from a report of the McKinsey Global Institute. And it tells a quite compelling story, namely that within the next, let's say, 10 years, about 60% or even more than 60% of the global GDP growth is going to come from about the 600 largest cities in the world. That means by 2025, we will see that not only 60% of basically the global economic output will come from only those 600 cities, but at the same time we will also see that about a quarter of the world's population is going to be found in those cities. So that kind of tells you that it's worthwhile thinking about last mile distribution in large urban centers, because last mile distribution will immediately affect the consumers, but also the businesses that create these numbers in those large urban centers. And when we typically talk about megacities, I mean, there's various definitions of what a megacity could actually be. We usually use a very simple definition, which is a city with more than 10 million people. That's typically what we call a megacity. And right now we have about 25, 27 of these, and by 2025 we're expecting to see around 40 of these megacities around the world. And as you might guess, most of them are actually going to be located in the emerging markets. And that's why looking at emerging market megacities is most interesting for us from a logistics point of view, and probably also for you from a business point of view. So to underline why it's actually relevant to look at the last mile of the supply chain in particular, it's relevant to understand that the last mile is actually the most complex and the most costly part of the supply chain. At least that's what we try to tell companies to convince them that it's worthwhile working with us. But to basically make the case, I wanted to show you an example from UPS. So UPS in the US alone operates a lot of delivery routes, obviously, and each of these delivery routes on average comprises about 120 delivery stops on a single route. So if you do the maths, it's easy to compute that you can combine those 120 stops in a lot of ways. This is actually the number of possible combinations, theoretically possible combinations of those 120 stops. And I don't even know how to pronounce this number. It's a 6 with, I think, about 198 zeros. So it's a big number. Obviously, only a small fraction of these combinations is actually feasible and makes sense. But nevertheless, I think that underlines the combinatorial complexity when it comes to decisions like how do I efficiently route my delivery vehicles in a large city with that many stops. And the economic potential of this comes clear, I believe, when you think about this only being a single route. However, UPS in the US alone operates about 55,000 routes every day. And so this was published in an article of the Wall Street Journal about a year ago. And they made the math, or they did the math, and came up with a calculation that said if they managed to reduce the average length of such a route by about 1 mile, that would save them about $50 million every day, only in the US. So that kind of gives you a feeling for the economic potential that lies in efficiency gains, but also the economic threat that lies in efficiency losses when you think about serving urban markets. So I told you earlier that most of the economic potential, or most of the economic growth within the next couple of years is going to come from emerging market cities. So what are the particular challenges for last mile operations in those cities? And I think one of the most important challenges is density. I'll get to this picture in a bit, but when I say density, then we have to think about different levels of density in, let's say, emerging market megacities compared to industrialized cities. To illustrate that a little bit further, let's look at New York. New York City is probably one of the most dense areas in the Western industrialized world that we know. In Manhattan itself, we have an average population density of about 25,000 people per square kilometer. Sorry that I'm doing this in kilometers because I'm German. I hope you forgive me for that. But so 25,000 people per square kilometer is quite a bit of people per area. But as you increase the definition of New York from not only looking at Manhattan, but looking at the greater New York area, that already pretty quickly declines to about 10,000 people on average per square kilometer. If you move further out to the metropolitan area, you end up with about 2,000 people per square kilometer, and that's a pretty normal range, I would say, for a decently sized North American or European city. Now, if you compare that to a very well-known city in the emerging markets, namely Mumbai, the picture looks like this. You go to the furthest extension of how you could define Mumbai, and you end up with about 30,000 people per square kilometer, only in that wide definition of the city. So that's already like 20% larger or more people per square kilometer than in the most dense area that we can find around here. And that, I think, gives you some idea of what we mean with extreme levels of density in the emerging markets. And if you look at that picture in the background, that's actually a Google Maps, Google Street View screenshot from Bogota. And it kind of gives you a feeling what density means from a logistics point of view. Because you could argue, well, why do I care about population density? I'm driving trucks. But if you look at this picture, you see a lot of different stakeholders comparing for one very scarce resource, which is actually infrastructure. So you see infrastructure, in this case roads, are a very limited, very scarce resource, and everyone tries to get his or her share of it. You have pedestrians there, you have public transport, private transport. You see actually in the background quite a few delivery vehicles that try to deliver stuff. You see, for instance, this guy here, the beer delivery man, who basically already gave up on going to his customers with an actual vehicle because it's not efficient to operate a vehicle route in this environment. It's more efficient to just walk. And that, looking back at the UPS example, tells you about how much money you could actually gain or potentially lose if you do last mile logistics more efficiently in such an environment or not. So where do all these people shop that you saw in this picture? And coming from a North American or European background, you might think, well, you go to a supermarket. But that's actually not the case. In most countries of the emerging markets, the traditional retail sector, so basically what we call in our research nano stores, is very often the most or the dominant part of the retail sector. So you have those small single owner operated retail outlets, very limited in space. Usually they don't even have a storage space that's dedicated to their store, but all their inventory is basically on the shelf. And if you look at the assortment that you see in those pictures, something immediately or hopefully comes to you, like catches your eye, which is of every product, they usually only carry about one, maybe two brands, because there's simply not enough space. And actually in this kind of environment, you also compete differently for being part of the assortment of these stores. Brand and probably price is not necessarily the most important factor. If you look at this, for example, you see one major problem of these stores, which is logistics. They don't have the space to handle goods. They basically get their new product delivered, they dump it on the street, and they somehow have to fit it into their limited space inside the store. So what we learned from working with a lot of manufacturers and retailers in such markets is that actually an important competitive factor is to what extent you support those nano stores on the logistics side. Does your driver not only drop the beverages, but does he also help the store owner to put everything into the shelf? Sometimes some companies even take over the inventory management part of the store owner's responsibilities. And all of these added services have a much higher importance if you're talking to an owner of such a store, rather than if you're talking to the manager of a larger supermarket. I don't want to go into too much detail for why the traditional retail sector is so important in the emerging markets, but one very important aspect I think I wanted to point out, which is the access to the formal banking sector. Because consumers in these markets often don't even have a bank account. They don't have a credit card. They don't have a debit card. They have no access to getting formal credit. They live from what they get during the day. They have no money to actually go to a supermarket and pay for a whole bucket full of merchandise, but they probably just have the money to buy what they need to survive for the next 1 or 2 days. So even if they had access to the large big box retailers, they will probably not be able to shop there because they don't have the money, they don't have the means to pay there, and the pack sizes that they get in those outlets are too large for them. Whereas in the nano stores, it's more relationship based. They get informal credit, they can buy individual items, they can even buy bulk, so just like the amount of rice that they need for the next day, which is not possible in the modern retail channel. So to give you an idea of how this ties back to last mile logistics, this is a screenshot that we made from a GIS system, so Geographic Information System, where we populated with all the locations of nano stores in Mexico City. This is a random part of Mexico City, and you see all those green dots. In each of these green dots is actually a little retail outlet. Each of these dots is a little nano store that needs to be replenished by people like Anheuser-Busch, like Coca-Cola, like Bimbo, who in Mexico City basically is a big provider of bread and all that kind of stuff. And if you look at the inventory levels of these stores, and we relied on data from the Statistics Bureau of Mexico City for this, you see that the large majority of these outlets doesn't carry more than 1 or maybe 2 days of inventory. So what that means is that every single green dot on this map needs to be visited almost every second day. And that ties back to the number of stops and the density aspect that we discussed earlier, and should give you an idea of how difficult it is to actually operate last mile logistics in such an environment while still being profitable. Because you have a lot of stops with very small drop sizes, you're in the densest environment that you could be in, it's congested, it's very hard to get there with big vehicles, so you really need to think how you make those operations more efficient. Moving a little bit away from the emerging market setting and looking also basically at the general transformation that we see within customers, one other important aspect that you have to think about when you talk about last mile logistics is rising customer expectations. I guess you're all familiar with Google Express, Amazon, and the like, and all of these services have over the last couple of years educated the consumer to be expecting more. The consumer is expecting ever faster deliveries, ever more flexible deliveries. The consumer nowadays is used to getting same-day delivery for free almost. The consumer is used to being able to basically reschedule his delivery up to the day when the delivery was initially scheduled. He's used to being able to change the address or even the delivery model with which he receives the good up to the very last second. And that, of course, increases the complexity of last mile operations tremendously. So basically, you could say that with the emergence of things like the smartphone in 2007, the first iPhone came out, we did not only move to, let's say, an omni-channel retail experience. So consumers did not only start to expect to be able to switch between different channels for discovery, search, purchase, delivery, and also return of goods. But we also needed to provide the necessary logistics backend to actually be able to realize this. So the new buying process could be characterized with the headline, anytime, anywhere. So the consumer is being used and is expecting to be able to do everything, every step along the buying process on every possible device, in any possible location, at any possible time throughout the process. But to actually make this possible, you need the necessary last mile logistics networks in the background that are flexible enough, reliable enough, and efficient enough to provide such services, but to also still make money on it. And that is where actually density in urban areas is not a curse, but a blessing. Because, so I wanted to illustrate this with an example from New York City. So in New York City, there was a study done a few years ago. Basically, people tried to find out how far can I go in New York City if I jump into a cab and ride for 7 minutes. I don't know how they came up with 7 minutes, to be honest, but it's just an example. So, and they found out on average you can travel about 1.3 miles within 7 minutes, and since I'm German I have to translate that to square kilometers, and that means within 7 minutes you can reach an area within Manhattan of about 6 square kilometers. Now earlier we saw that there's about 25,000 people per square kilometer, so that basically means that within 7 minutes from any point in Manhattan you can reach about 150,000 people. And that is exactly the level of density that you need to have the necessary scale to actually provide that level of flexibility and still have enough people to basically ask for the same thing, so that you can realize efficiency gains, for instance, when you're routing your vehicles. So you don't have to go to an individual customer somewhere in the middle of nowhere that requests that very specific delivery service, but you're sure that you will always have sufficient people in a sufficiently small space that ask for the same service, so you can actually optimize over, for instance, your vehicle routes. Now, how do you choose the right model with which you serve urban consumers? Because, I mean, we all know home delivery, and probably by now we also all are kind of familiar with locker systems. So DHL started with this a couple of years back in Europe with their Packstation, which is basically a smart locker system where, as a consumer, you are probably buying something from Amazon, and you, instead of ordering it to be delivered to your home, you order it to be delivered to such a locker station. And for you, that's convenient because you can pick it up there at any time of the day that you want. After work, for instance, a lot of these locker systems are located at subway stations, for instance. So you can go there on your way back from work, pick your package up. You as a consumer are happy, and in this case, DHL is happy because they have one delivery point where they can drop a large number of packages. They are sure that they're going to be delivered. They have basically 0 return deliveries, and they are much more flexible in questions like, when do I replenish such a locker system, because they do no longer have to adhere to individual customer time windows. And now here in the US, I think Amazon has started rolling out Amazon lockers somehow with the same idea in mind. But that's a very basic technological advancement that has somehow changed how last mile delivery is being done, at least in the more industrialized part of the world. But there's more to come. I mean, everyone talks about drones. So you basically need to have a drone in a presentation if you talk about last mile. Otherwise, people don't believe you. We personally, our group doesn't really believe in the big potential of drones in an urban setting. But that's a whole different talk, so I'm not going to go into that detail. But you have a lot of different developments. One development that I personally believe in quite a bit is everything that's happening in the realm of smart homes. So for instance, we are working with a company in Sweden who develops smart locks. And the idea is kind of similar to the locker system, just that you don't have a central locker that can be served at any time of the day, but you actually grant a delivery company like DHL access to your home. So by now we're all kind of used to people like Instacart delivering groceries to our doorstep, given that there's someone who can receive those deliveries. But now the idea here is, and they piloted that with Sweden's largest supermarket chain already, the idea is that the delivery man can actually enter your apartment, drop the stuff in the fridge and leave your apartment again. And thanks to smart home technology, you can actually make sure that he really only goes to your fridge and nowhere else. So that can help mitigating the obvious safety concerns that there might be around these solutions. Together with the Media Lab, we have also spent some time thinking about autonomous vehicles, obviously. Autonomous ground vehicles, I believe, in an urban setting might have much more potential than actual autonomous aerial vehicles. And probably you have heard about a development by Mercedes-Benz that was published a few weeks ago, where they actually came up with a combination between a conventional ground vehicle, like a van, and they connected that with drones. So the drones would basically use the van as a home base, and then the van would stop somewhere within the city, and the drones would fly off and deliver really only for the last few meters, which from an economics and also from an energy efficiency point of view makes much more sense than sending drones from somewhere out of the city back into the city center. So this is just basically a collection of things that could happen and probably will happen in the future that can transform the way that last mile logistics is being done in the future. But the question is, how do companies actually decide which delivery models to choose, which customer groups, and which areas within a city to serve with which kind of delivery model and which technology. And the answer is not simple, because if you look at this, this is basically an aerial view of a part of Mexico City again. And I don't know whether something comes to your mind when you see this, but basically what this should tell you is that it very much depends on real-world constraints, I would say, like what delivery model is actually feasible, not only economically, but also physically feasible to employ in certain areas of a city. So this obviously is more like a favela area, but what you see is there's a lot of different factors that you have to take into account when you choose the right delivery model. Look at this picture and think about road quality and road capacity. It's simply impossible to go there with an 8-pallet truck to deliver Coca-Cola, for instance. If you think about addresses, I mean, how does a delivery person actually find his or her way in this? In a lot of these places, you don't even have a systematic address system, but you go by a point of reference. So you need, and that could actually be enabled by technology, you need, for instance, smart algorithms that translate a point of interest-based description of an address into actually accurate GPS coordinates that you could use as a delivery person to find the place where you have to drop your merchandise. Another aspect, something that we discovered in a recent project that we did in Brazil, is safety. So in these kinds of areas, the dominating factor that determines which kind of vehicle you use might actually not be the capacity or the physical characteristics of a vehicle. It's more which vehicle is the least obviously a delivery vehicle. So they sometimes go in those areas only with a car, not because it's the most efficient vehicle option to choose, but because it's the safest bet not to get robbed. Or they might decide to accompany such vehicles with armed guards or with other technology solutions to avoid or to minimize the risk of being robbed or to increase the likelihood of getting goods back in case they get robbed. This is another picture from Sao Paulo in this case, and that should illustrate another point, namely that there's no one-size-fits-all solution to a single city. In Sao Paulo, here you can see pretty nicely that there's a high level of heterogeneity in the way the city looks like. So you will most likely not use the same delivery model to serve the areas down there in the lower end of the picture, because these are like single homes, single drop sizes, basically classical home delivery. You go to the door and drop a single shipment, whereas in the back you see all those high-rise buildings that by themselves already kind of act as an aggregator of demand. So you may only have one stop per vehicle, but that stop might actually fill your entire vehicle, because there's so many customers at only one stop that you basically need to think about, do I really want to use the same vehicle to serve the customers up there as the one that I use to serve the customers down here? So bottom line is, a city is not a homogeneous kind of entity. You really have to identify sub-areas within every city, both from a socioeconomic point of view, but also from an infrastructural point of view, to figure out which areas you want to serve how and with which kind of technology. And so basically what you want to come down to, and don't worry, it's not getting more theoretical than that, but is a model that tells you, for any given city that you have, how do I want to design my last mile distribution network? And that contains questions like, where do I want to locate distribution facilities? Like, where do I want to put my warehouse? Where do I want to put my little transshipment point, for instance? Then on the next level, you might want to ask, so which part of the city do I want to serve from where? Like, what's the facility that should serve a certain neighborhood within my city? Then the next question is, which delivery model do I want to use? So for instance, where do I locate my locker systems within that city? Where are the most beneficial locations to put up those locker systems? Or if I want to use crowdsourced on-demand models to serve my rush deliveries, for instance, how do I choose which areas of the city, which neighborhoods I actually want to serve by myself with my own vehicles, or by someone like DHL, or by someone like an Uber driver? And last but not least, how do I add flexibility to my network? So this is actually taken from TNT's pilot a few years back in Belgium, but we see this being used on a daily basis by, for instance, Coca-Cola in Rio. where you use a big truck, trailer truck, to go somewhere inside the city and use that as kind of a mobile depot. And then like a large number of smaller vehicles, in Coke's case it's actually motorcycles, comes to that trailer, picks up the Coke and delivers it to the really most dense and congested areas of Rio de Janeiro. And that allows you to include flexibility in your distribution networks, which also has benefits like it allows you to serve peak demand periods better without having to establish physical facilities. So you might have a few weeks around Christmas, for instance, within the year where you really have a lot of demand, but you really don't want to build another warehouse somewhere, but you would rather rely on such more flexible, more mobile solutions to increase your distribution capacity only temporarily. And this ties back to the question, how can we use data to inform such decisions? Because looking at such a model, obviously, the decisions that you make with a distribution network design model like this can only be as good as your ability to model reality. So whenever you build a model, in our case mostly scientific models, you have to get as close as possible to reality to actually encourage decisions that help the people on the ground. And for that you need to use as much data as you can to actually calibrate your models in a way that they reflect reality. For instance, coming back to the example of Sao Paulo, there we are working with a company that is basically the Brazilian Amazon. It's B2W Digital. I don't know whether anyone in the room is from there, but so they are basically like Amazon in Brazil, and they operate their last mile distribution themselves. And for them, we are kind of thinking about how can we design last mile distribution networks for their company in the major Brazilian cities. And of course, one important aspect is travel speed. So how do we figure out in which part of the city our vehicles can travel how fast? And this is a screenshot. It's a bit blurry, unfortunately, but what you see there is about 2 months worth of data of GPS traces from their vehicles. So we use those GPS traces to calibrate for every single square kilometer of Sao Paulo, like the distribution of travel speeds within those square kilometers. And that allowed us to make a much more precise estimation of travel times and therefore also routing cost to serve B2W's customers in basically every part of Sao Paulo that they serve. Similarly, you could use GPS traces or also mobile phone data to first of all identify what's going on in your operations. This is taken from another project that we did in Santiago, in Chile. And this is the downtown area of Santiago, and this is basically just a heat map informed by GPS traces from the trucks of one of the companies that we work with. And you can use this to basically identify where do those trucks usually park to deliver their goods. So from the big blurry red stuff, we basically identified the red dots that you see in the other version of that map. These are basically the most prominent parking locations within Santiago. And compared to that, we also plotted the most important customer locations. And by looking at that map, you can already, by only looking at it, identify certain inefficiencies. So some of the big customers are for some reason not close to a prominent parking location, which means there's a lot of walking involved just to get to those customers. And that might be due to congestion, might be due to access restrictions. But this basically helped the company already to identify where are we losing money in serving that highly dense and highly congested area in Santiago. Similarly, data can help you make better assumptions for your last mile distribution network models. This is an analysis of another company that we work with on stop times. So basically we try to measure how long does it take them to drop off the goods that they need to deliver to a certain customer. And basically on the x-axis you see the size of the order. Is it just one package or is it like 20 packages? And on the y-axis you see how long did it take us from the time we stepped to the doorstep of the customer, rang the bell, until the time that we returned to our truck. And you can see there's a nice correlation. So obviously the more you deliver, the longer it takes. But what you see if you look a little bit closer is that there's two distinct populations of customers obviously in that data set. And you might want to ask yourself, why is there a second population that is for some reason significantly different from the rest of the customers? That for some reason takes like systematically more time to serve. And only by adding additional context information you can actually find answers to these questions. In this case, what we did was we plotted the customers on a map. And basically, by looking at other factors like socioeconomic factors within the area, building structure within the area, and infrastructure, we identified certain areas within the city that exhibited a high density of those higher stop time customers. And by digging a little bit deeper into the data that we had, we found out, well, most likely these are people who live in high-rise buildings. Because there, the delivery guy doesn't only go to the door and drop the package, but he has to go to the concierge, take the elevator, go up, drop the package, take the elevator down again, and go back to his truck. So there's a systematical difference in how these customers are being served. And this is something you have to capture through data once you want to model your delivery operations in such an urban environment, because otherwise you basically systematically underestimate the cost of serving this particular group of customers. And last but not least, I wanted to start with something exciting because I know this is the last talk of the day. And we worked with some colleagues here at the Media Lab who developed this fancy Lego table and connected it to one of our research models, because we believe that building fancy research models is great from a research point of view, but we always really want to have real-world impact. We want the people that we work with in industry to understand the models that we build. We want them to understand and to use the models themselves. So here we basically work with a company that is concerned about last mile delivery of perishable goods. And they wanted not like a black box solution that would tell them this is the optimal solution, this is how your network should look like. But they wanted a simulation model with which they could play around and understand themselves what happens if I design my network in a certain way. So what you see in this model is you can basically use, in this case, a very simple technology, namely Lego blocks, to locate, let's say, stores or distribution centers or locker systems within the map. In this case, I think we see the map of San Francisco. And as you place a new part of the distribution infrastructure, you immediately see the effect that this has on the coverage area that you can achieve, on the performance of your network in terms of delivery cost, on the risk that is embedded in your network in terms of do I serve my customers on time or not. So you could basically intuitively play around with network design for an urban market. And this looks very simple, but basically this takes all the information that I talked about earlier into account on the back end. So we feed this model with very high resolution information, for instance, on customer density, on income levels, for instance. You could feed it with real-time information on weather or on traffic. But the interface is simple. The interface is visual, and it allows people to have an immediate response to a design decision they make. And maybe they don't get to the mathematical optimum of the distribution network design that we would suggest if we just ran an optimization on this. But they understand the trade-offs without understanding the mathematical details behind. And that's important for corporate decision-making, but also for teaching. For instance, if I teach an MBA student something about how do I design urban distribution networks, it doesn't matter to him how it's modeled mathematically. He wants to get the insights. He wants to understand what are the key trade-offs that I have to keep in mind when I go out into industry and have to make that decision without having a big research team in the background that can build a fancy model. And that's why we basically designed this system. And to finish up this talk, I just wanted to say that this project has actually had such great impact and was so well received that we will launch this as a separate research agenda next year at the Center for Transportation and Logistics. We're going to build a separate lab space around this idea of interactive data visualization, interactive visual interfaces with scientific models. Because we believe that data visualization and also like the fancy buzzwords like augmented reality might actually have some real-world impact if they are applied in the right way. We believe that there's huge potential, for instance, in augmented reality solutions for better supply chain decision-making. It can be used to visualize data, to visualize information, but also used as an interactive interface, as an intuitive interface to the models that we build. And we hope to use this technology in the future to have more impact in the real world, be it by working with companies or be it by working with cities, for instance. And I think my time is up, but thanks for staying with me this late in the day.